square root of 169, type that in the calculator, it is 13. For the second one, the negative is on the outside of the radical, so we leave it on the outside and we evaluate the square root of 9, negative 3. When it's a fraction like this, you take the square root of the numerator over the square root of the denominator. You cannot take an even root of a negative number. These are going to be not real numbers. For this one, make sure that you're entering it in the calculator correctly. You do 3, the second button, caret, square root of, then type in 343 equal, you get 7. The cube root of negative 27, we can take an odd number root of a negative, type that into the calculator, you get a negative 3. All right, the fourth root, it's an even root with a negative number under the radical. We cannot do that. It is not a real number. In number 8, we're going to multiply the part and put it, the two numbers, and put them under the same radical sign. 2 times 18 is 36. Now I want to simplify the radical. What is the square root of 36? 6.
Ms. Alma.
Yes.
So what makes the top one not a real number? You said the negative.
Because it was an even root. So if I'm taking the square root, the fourth root, the sixth root, I cannot have any negative numbers. Those are all going to be example of not reals. Okay, but we can take an odd root like we did for that negative 27, because that was a cubed root.
So even number on the outside
And if there's no number, because if there's no number, that's an understood too. Then if you have a negative, it's not real.
Wait, hold on. Hey, what made 7 not a real number? The 4?
The negative underneath, the fourth root.
But on 6 it had a negative 2.
Oh,
Because it was
okay, so on the 6, because, think about this, negative 3 times negative 3 times negative 3, right?
Yeah.
This will give me a 9, and a 9 times a negative 3 gives me a negative 27.
Mm-hmm.
But when you're doing evens, like if I tried to do this one with 625 would be 5 to the fourth root. If I tried negative 5 4 times, this would give me a positive 25. This would give me a positive 25. I'd end up with a positive times a positive, so it has to be a positive number. So, and it's because of the even roots. 2 positives make a negative when you multiply or divide. So as long as it's an even number, 2, 4, 6, 8 root, you can't have the negative underneath. All right, number 9. To simplify the radical, because if you type this in the calculator, it's going to give you a decimal, but we don't want approximations, we want exact answers. So to simplify it, you're looking at your list of your perfect squares. These lists will stay up here, okay? So you'll have them to use for your test on this and everything. You want to see if the biggest perfect square that goes into this, that is a factor of 12, and it would be 4. So we're going to separate the square root of 12 as 4 times 3. Now we evaluate the square root of 4. The square root of 4 is 2, so it comes out of that radical, and we still have a 3 under the radical. So that is our answer, 2 square root of 3. To check your answers, if you typed square root of 12 and hit equal, you'll get a long decimal. If you type this, hit equal, you'll get the exact same decimal. That's how you know you're right. Okay? All right, square root of 40. Again, I'm looking to see if I can separate it into a perfect square. This can be separated as 4 times 10. I can take the square root of 4. It is 2, so it comes out of the radical. I'm left with 10 under the radical. 2 square root of 10 is my answer. For the square root of 65, looking at my perfect squares, I know that 49 won't go into it, 36 won't go into it, 25 does not go into it, 16 does not, 9 does not, 4 does not. This one cannot be simplified. the square root of 112. So the way that I do these, I start with I just kind of look at the numbers, and I'm going to start for 112. I might start with 81, but I really know it's not going to go into it. Let's try 64. I do the divide. I see I don't get an even number. I arrow up. I'm going to change my 64 to 49. Still does not go into it. Let me try 36. Does not go into it. 25 does not. What about 16? 16 times 7. So I'm going to separate this as 16 times 7. The square root of 16 is 4, and I still have under my radical the 7. So a lot of this, it's not that it's hard. It might be a little time consuming because you have to try things in the calculator. But the calculator's doing the work, so it's fine. It's not too difficult. No, please let me know if I'm going too fast. All right, 4 times the square root of 63. I have to leave that 4 on the outside. I want to separate 63. Looking at my perfect squares, 25 won't go into it, 16 won't, but 9 will. That is 9 times 7. I still have the 4 outside, so when I take my square root of 9 and get 3, I'm just going to put it in parentheses. What's left under the radical is still a 7. I need to simplify by multiplying that 4 times the 3, 12 square root of 7. It can. So the next one, this negative is outside of it. Okay? So I'm going to leave it there, -6, and then under the radical, I'm going to separate 50 into 25 times 2. My -6 is still there. When I take the square root of 25, I get a 5. And what is left behind of the radical is still that 2. -6 and +5 give me a -30, and I still have my square root of 2. Square root of 500. Let's separate that into 100 times 5. What's the square root of 100? 10. I still have 5 under the radical. So Patrick, you said 25? Okay. Don't write this down. I just want to show you this. 500, I can separate it. It goes 25 times 20, okay? I can take that square root of 25 out to give me 5 square root of 20. But square root of 20 can still be separated as 4 times 5. Then when I take that square root of 4 out, I'd get a 2, and I'm left with the 5. I'd still end up at the same place. So it's better to try the biggest number possible. But if you don't, and you have something like this, just try to make sure that you look at what's under the radical and make sure that there's no more perfect squares that'll go into it. Okay? All right, so when we start with our variables, I'm trying to take the square root of an x cubed. I know the square root of x squared is just x. So it makes it easier if I separate that. So just like I separate the numbers, 45 becomes 9 times 5. I'm going to take my x's and make it x squared times x. Remember, x squared times x is equivalent to x cubed. But I separated it because I want to take that x squared, I want to take the square root of it and get it out of the radical. The square root of 9 gives me 3. I still have the square root of 5 underneath. The square root of x squared, when it comes out, is just an x. And I still have an x underneath the radical. So that is my answer.
Why you kept the x in? Like outside?
So I had separated as x squared times x. When I take the square root of x squared, that makes this x come out, but I still had 1 underneath. So I leave it there. The cube root of negative 125, you can actually type that into the calculator. It'll give you a negative 5.
Excuse me,
Yes.
why you had to do the x squared and then another x1 and not just do x3?
Okay, so I could have done x cubed, right? And what we're learning like later today, and I went back and forth as to like switching the order of it, but yeah. In order to take the square root, I need it to be a perfect square or an even number, okay? So I separated x cubed as x squared times x. Do you see how those are equivalent? X squared times x is the same as x cubed.
Mm-hmm.
But the reason I did that was so I could take this x squared out.
Right, yeah, I got you.
All right, let's look at this next one. I can take the cube root of negative 125. It's going to be a negative 5. But if I'm thinking about my cube root of x to the 6th, okay, I could separate x to the 6th as x cubed times x cubed. How many x cubes can I take the cube root of? So each one of these would give me an x. I'd end up with x squared because I could take out this x. I could take out this second x. There is a shortcut to this so that I don't have to write all of this out. The shortcut is saying that, and this is kind of what we're learning today as well later, if you take this exponent, you divide it by whatever the root is. So this is actually x to the 6th divided by 3. When I take it out, it becomes an x squared. If I would have done that with the one up at the top, so it was x cubed, the root when it's not written is a 2. If I were to divide this by 2, I would get 1.5, right? Right? Let's think about long time ago when we did division. 2 goes into 3 one time, and I have 1 left over, like a remainder of 1. Y'all remember doing those way back in the day? So that means I could take 1x out, and there would still be 1 left under. And I don't know if that's going to make it even more confusing for you or what. But when we practice these, you'll see how they work better. If you haven't, whatever the root is, you want that to not, exponent to be a multiple of it. All right, so right here, I could take out these 2x squared. So I end up with a negative 5. I take out 2x cubes when I take the cube root, so that means I took 2 out. It's going to get easier, I swear, I swear, I swear. All right, let's look at 18. Leave that 2 alone. Under the radical, 32 is 16 times 2. For the A, so my A is to the 17th. I'm taking the square root, so I want my variable to be an even number, my exponent on my variable to be even in order to take it out. I'm going to make this 16 times a to the 1st. So a to the 17th, this 17 is equivalent to these when I add their exponents. I just separated them. Now when I take out, I have my 2 that's out here. The square root of 16 is 4. The number that's still left under the radical is 2. When I take a to the 16th power, what I'm really doing, and I'm going to go off to the side to show this, is I'm dividing it by 2 because that's what root I'm taking.
It's gonna be 8 to the 8.
It's going to be a to the 8th on the outside, and I still have an a underneath.
Because you divide it by what?
You divide by whatever this root is. So on this one, we divided it by 3
So the root is 3, huh?
because the root was 3.
So that,
This one we divided by 2. It didn't have anything written, but we understand that to be 2.
So Ms. Allen, say like they didn't have a number in front of a square root. There would be a 2, right?
It's understood to be a 2. They just don't write it.
Oh.
so.
Okay?
So that 8, like, so
The one that's just a regular 8, that always will go
That's
under
gonna
the thing.
stay there, yeah,
And it always will go under the square, whatever.
yeah,
Okay.
yep. All right, but I'm still not done, I gotta multiply those two numbers. So this should have been 8a to the 8th times the square root of 2a as my final answer for that one. All right, my 4 is on the outside, I'm leaving it there. I'm taking the cube root this time. I want to look at my perfect cubes over here. 1, 8, 27, 64, 125. I want to see if I can separate 373 as two factors that has a perfect cube. 375 is 125 times 3. I'm taking the cube root, so for my x to the 4th, I'm going to write it as x cubed times x. X to the 4th is the same as x cubed times x. Because remember when you multiplied, what you had done was added exponents, so this is the same as these two put together.
So y could be y cubed to y to the 4.
Yes, yes. So my y to the 5th, I'm going to have y cubed, and I have 2 more left. When I simplify it, don't forget about the 4 out here. The cube root of 125 is 5. Under my cube root, I still have this 3. I'm going to leave it there. I can take the cube root of x cubed, gives me an x outside of the radical. I still have 1 inside.
You damn lost me now. You lost me.
No, the one that has the one, you always, it goes inside.
X squared or something like that.
So, but I'm taking the cube root. That's why I needed these to be 3s.
Oh, alright, so it is one.
So this, if I took the cube root of x cubed, I just take the x out.
So if that 3 at the front was not there, it would have been 3.
No, it's the 2.
If there wouldn't have been a 3 here, it would have been a 2, and then I would have left it as the 4. Yeah. All right. It's okay. This y cubed, the cube root of y cubed brings a y out. What is left underneath is y squared.
The one that's less, whichever one is less goes on.
It's kind of the same concept.
4 times 5 is 20. xy, cube root, 3xy squared for the final answer.
See, like it's like the bottom part is the easy, like the 20xy. That's the easiest part.
Yes.
So, like the part.
Whatever is the less, I just know like the x and y go outside regular, like not squared or nothing.
Once you take the root of it, yeah,
Yeah, it's regular. And then like whatever is like the less y, like y squared out of like.
yep,
the less-
stays under.
All right, question. So the so how you got the middle question, the middle equation, the square root of 3x. Where you got the 3x from again?
Okay,
She split
hold
up
on. So this x to the 4th, I split it as x cubed times x. When I take the cube root of x cubed, those cancel each other out, and that x comes out of it.
Oh.
But I still had, so this came out, I still had an x left. That's why this one is still here. When I take the cube root of the y cubed, it takes it out. It shows up outside now.
Cause they got a 3 outside.
Mm-hmm. And what was left behind inside that radical was the y squared.
So say like they didn't have a 3 and it was like just a 2. That y squared would cancel out, so it just be y, right?
Correct. So if I'm taking the square root of y squared, it would just be y. All right. Let's go to the next one.
Oh.
All right. Square root of y to the 9th. Remember that if it's not written, it's a square root. I want it to be an even number, so I'm going to do y to the 8th times y. That's the same as y to the 9th.
One y's gonna go outside and one's gonna go in.
So remember, I'm taking, what I'm really doing here is the 8 and I'm dividing it by my root that I'm taking, the index.
Which is 2. You're gonna get it.
Because
one
the 8,
Split it.
yeah, I split the 9 into y to the 8th times y to the 1st.
Y 4 outside?
And now I take the square root of y to the 8th, it's y to the 4th. On the outside,
On the inside, you get 1 Y.
on the inside, I still have another y.
Yeah, boy. This is getting easy.
The more you practice it, the easier they do get. All right, square root of 10 times the square root of 70. I'm gonna multiply those first, which gives me 700. Now I wanna see if I can simplify it. I'm gonna separate it into 100 times 7. The square root of 100 is 10, and I still have the 7 under the radical.
So you got the 700 because 10 times 70, right?
Yep.
Okay.
Couldn't you just divide 70 by 10? Rather
Huh?
than multiplying?
I don't understand.
Rather than multiplying 10 by 70,
you get
couldn't you just divide and still end up with 10 and 7?
Like, I don't see how you're doing that.
She wants
That's
you
how
to
you get
divide
70
70 by
by
10.
You gonna make it more confusing.
Why would I divide 70 by 10? This is multiplication.
Because you'd still get the same answer is what I'm saying. Like if you just divide 70 by
Oh, you mean if I just take this and just say like divide by 10, divide by 10? No,
No, not both sides, just the other, like. just
no,
70.
that's not always gonna work that way. Okay, it won't always work that way. So like, 3 times 6, you'll see when we get to this one, I can't just divide the 6 by 3 on this next one. You have to multiply it first and then take the square root, because the square root is not dividing by a number. It's asking how many times the number's used as a factor. All right, on this one, I multiply the numbers outside. 3 times 7 is 35. Now I multiply the things under the radical. 3 times 6,
X squared.
18, x times x, x squared. I leave that 35 out here. My square root, I'm going to simplify by separating 18 into the factors 9 times 2. And I have my x squared still. I can take the square root of 9. That gives me 3. That still leaves me a 2 underneath. I can take the square root of x squared. That takes the x out. So my final answer, I just have to multiply 35 times 5. 105x square root of 2.
The original X went inside because you didn't have another X. You didn't have 2 X's, right?
Correct. $45 times 12 gives me 540. X squared times x to the 4th, we add the exponents, gives me x to the 6th. Y to the 4th times y cubed gives me y to the 7th. I want to find my perfect square that goes into 540, but I want to find the biggest one I can. So in my calculator, I just do 540, and I'm going to start down here with the bigger numbers. 81 does not go into it. 64 does not go into it. And I'm going to try all these big numbers. Does 36 go into it? 36 goes into it. So I separate the 540 into 36 times 15. My exponent on the x is an even number. I'm leaving it that way. For my y's, I want it to be an even number, so I'm separating y to the 7th into y to the 6th times y to the 1st. The square root of 36 gives me 6 on the outside. I still have a 15 inside. the square root of x to the 6th. What you're basically thinking about is 6 divided by 2 because this is a square root.
It'll be 3, huh?
I bring out x cubed. Same with the y. I can bring out, if I divide this by 2, I bring out a y cubed.
One Y goes inside.
I still have a y left inside. All right, on this one, I'm going to divide those numbers first. 12 divided by 3 is 4. That makes this a much easier problem to solve. What is the square root of 4? 2. I like those.
I like it with just the, I put the square root. It was easy, but just add on. Square root,
Yeah, if you type this in like this, square root of 12, close out parentheses, divided by square root of 3, you'd still get the same answer. All right, for number 25, I'm going to put them under a radical. I'm going to simplify the fraction underneath by doing 486 divided by 18, and it comes out to 27. So, remember when you multiply a common base, you add the exponents. When you divide the common base, you subtract the exponents. X to the 10th divided by x to the 4th, I subtract 10 minus 4 and get a 6. Y to the 11th, I really can't see. That glare is just too bad.
7.
And it's divided by y to the 4th, so I subtract and I get y to the 7th. Okay, now let me see if I can simplify the 27 into something that is a perfect square. 9 times 3. My x to the 6th, 6 is even, so I can take the square root of it easy. For my y.
6 and Y1.
Mhm.
Times Y1.
Mhm. So now the square root of 9 is 3. I still have a 3 under my radical. To take the square root of x to the 6th, basically I'm dividing it by 2, and that comes out. Divided by 2, that comes out. There's still a y left underneath. Do you need some? Pat, you need some lead?
I got you.
You got some? Okay.
Rewrite that real quick.
As soon as we're done. As soon as we're done.
Alright, I'm ready.
All right, let's divide 150 by 2. I get 75. All right, for this one, so remember when you divide the common base, what you end up doing is subtract the exponents. 3 minus a negative 3 becomes 3 plus 3. If you do that in the calculator, 3 minus negative 3, you'll get x to the 6th. 75 is going to be split into 25 times 3, and I leave the x to the 6th since it's even, and I can divide it by 2 easily. The square root of 25 is 5. I still have a 3 underneath. Divide that exponent by 2, and I get to take out an x cubed. For 27, that one's really easy. Take the square root of 100, that's 10. Square root of 121 is 11. That's it. For this one, in the calculator, if you did 7, don't do division, but use that ABC fraction button, 7 ABC 63, it'll simplify your fraction into 1/9. for the y, when I divide, I subtract the exponents. What's left up here is y to the fourth.
And so it's gonna be at the top, cause that's what the biggest,
When I take the, and basically you're taking the square root of y to the fourth over the square root of 9. You don't have to write that you're separating it though. The square root of y to the fourth, think about it, we're gonna divide the exponent by 2. We can take out 2 of them. The square root of 9 is 3. So, if you're lost, I reopened the homework. Try to do the homework again, especially if you did not do it, because the more you practice these, the better it clicks. I promise.
What's on the top?
So this was a 4, so it was y to the fourth, but when I take the square root of it, what I did was I divided by 2 to get it out.
Send it to my face.